Okay, this will be part 2 of section 2.1. So 2.1, this will be part 2. I just didn't want to make this all because the video would have made it too long. So 2.1 part 2. Let's see if I can make this a little bigger. There we go. Alright, most of the linear equations are going to require more than one step to get their answer. So here, if we need to solve 7x plus 2 equals 54, first of all, we have to undo the times 7 part, so that this has to be undone, and we have to undo the plus 2 part. So the question is, which one do you do first? Well, this is basically the reversal of PEMDAS. If you remember, PEMDAS, that's the order of operations. So when we're working to work and simplify a problem, we go this way: parentheses, exponents, multiplies and divides, adds and subtracts. Well, now we're not building up to make it bigger. What we're doing is we're working to find and take it apart. So what we have to do is reverse. So we're going to start with the adds and subtracts. So you're always going to undo adds and subtracts first. So I need to subtract 2 on both sides. Then when I subtract 2, I'm still left with 7x. And over here I have 52, sorry, 52. So now 7x equals 52 goes back to just being a one-step equation. So I'm going to divide both sides by 7, and then I simply have x equals 52 over 7. Now 7 will not go into 52, nor do they have anything in common. This is an improper fraction. Okay, making it some decimal value does not make it any easier, because when we're working with algebra, when we're working with math, this improper fraction problem would be the basics of what we need if we had to take this answer and do something with it. So this is the answer that we would want to keep. Here we subtracted 2, so 54 minus 2 is 52, and then we have to divide both sides by 7. So I'm going to divide by 7, and it doesn't divide evenly, and it's going to give us some weird looking decimal value. So this is the answer that you're looking for. Now, there are questions on your homework that come up with strange looking answers. Don't expect that every problem is going to give you a nice pretty answer. So make sure to be careful with your signs, but don't be afraid to get fractional answers. You just have an ability, sometimes we doubt ourselves when we get an answer like that, because we have a tendency to think everything should come out nice and even, and it doesn't. Okay, so here, the way that I do these problems as an example is what I'm going to expect to see on a test. Okay, this is how you show your work, and this is what I've got to be able to see in order to grade. Okay, so here we've got to undo any adds or subtracts. We start there. So I'm going to undo the 8. It's subtracted, so I'm going to add. So I'm going to add 8 on both sides. Okay, so I'm going to combine, so I get 7x equals 42. Now divide both sides by 7, and this one comes out to be a nice pretty whole number, x equals 6. Okay, feel better about that one than you do when you get 52 over 7. Alright, now this side, we're going to do the same thing, but here we've got signs in here that could create a problem. So we've got to think in terms of positives and negatives, gains and losses, whatever you're looking for. So I've got negative 17. I'm going to get rid of the 17 by doing the opposite. So then I bring down negative 5x. And over here I have 2 negative numbers. Okay, I'm not multiplying, I'm adding. So if I lose $43 on the number line, if you think in terms of the number line, I'm going this way. If I lose 17 more, I'm still going that way on the number line. So that means I can't end up with a positive answer here. I'm negative. So how much is that going to end up being? Looks like negative 60. Now I'm going to divide by negative 5 on both sides. So I have a negative on the 60 and a negative on the 5. So negative divided by negative is going to come out to be a positive answer. So this time x equals 12. Alright, now here we have one with a fraction on it. Do not skip it because it has a fraction. You've got to persevere. You've got to do some work and think about it. So we need a number that 2 and 8 will go into. 5 doesn't have a denominator. Actually, it's a 1, and that doesn't affect us. So we need the lowest number that 2 and 8 will go into. Well, 2 goes into 8, and 8 goes into 8. Okay, so my LCD for this problem is going to be 8. Now, on the left side of the equal sign, I'm going to put an 8. On the right side of the equal sign, I'm going to put an 8. Now, I'm going to distribute and multiply it. Notice this time the 8 gets multiplied times a whole number 5. That's just 8 times 5. There's nothing, the 1 doesn't cancel with the 8. There's nothing. So just 8 times 5 would be 40. Then 2 as a denominator will divide into 8. So 2 will divide into 8 4 times. So I take the 4 and multiply it to the top. So that'll be minus 4x. Or think of it this way. What's half of 8? It would be 4. Okay, and over here the 8's will cancel off and I have equals x. Now, I have x's on both sides. I want to get the x's together. So I have to use the same process that I did here when I had to move the 17 out of the way. Now, I need these x's to be together. So since I have an x on the right hand side, I need to take this x so that it comes over and then I have numbers on the left and x's on the right. So I'm going to simply add 4x so that all the x's will accumulate on one side. And it doesn't have to be the left. It can be on the right. So now I have 40 equals 5x. Then I can divide both sides by 5 and I get x equals 8. Okay? More steps involved because we got to do some thinking here. We got to do some thinking, and having a common denominator is the tool that lets us get rid of the fractions. Okay? Now we got the same problem over here. I have x's on the left and x's on the right. So I don't want to have everything on the equation on one end. It's kind of like a seesaw. So if I've got x's over here, bring these to this side so then they're separated. So I'm going to subtract 2x and subtract 2x. Then I got a -4 and a -2, so I'm going negative, negative, so that means I'm going to still be in the negatives on the number line. So -68 is going to equal -48. And then I'm going to divide by -6. And x will be a negative divided by negative. If the signs are the same, the answer comes out to be positive. So this will also be 8 for the answer. Now, every one of these problems I gave you as examples have nice whole number answers. Okay? Don't always get thinking that's what it's going to be. Now, if you've got both numbers on one side and variables on one side, and over here you've got the same, then we have to do some more switching. So on this side, you have to decide, do you want your variables on the left or the right? Because it doesn't really matter. You can choose which one you want. You have to be careful with signs, but we have a tendency to always want to move the variables to the left because we read from left to right. So our tendency would be to take the -4 and add it on so that it moves over to the left. Then if you do that, your 7 has to come over to here. So if I move the 4 this way, the 7 has to move this way. So that way I end up with numbers on the right and anything with a variable on the left. So I'm going to do that. I'm going to add 4x and I'm going to line it up under the 2x. Okay, and then the 7 is going to come over here, so I'm going to subtract the 7 on both sides. Now go back. The 7's are going to be gone. The 4x's are going to be gone. So I have a -2 and a +4. So if I have $4 and I lose $2, that means I have $2 left. So 2x and a +5 and a -7. Well, that means I've spent too much money. I'm overdrawn by $2. So -2. Divide both sides by 2 and x equals -1. And there's our answer. Okay, over here Remember, always combine like terms. Before you start moving anything, always combine like terms. So I'm going to look here. I've got a -5 and a 9. So I'm going to add those together, combine a +9 and a -5. So 9, and I'm going to take 5 away from it. That'll be 4 plus 13y. Over on the right hand side, I can do some simplifying. I have a 15y, and then I have a +14 and a -16. So that means $14, and I'm spending 16. I'm going to be $2 in the hole. So I have a -2. Now decide which way you want to go with your variables and your numbers. This time I would take the 13 and move it to the 15, because that way my answer is going to end up being positive. Because I have a 15 and take away 13, I'll still have a positive number. It does not matter, but you have to be careful with your signs. So I'm going to take the 13 and move the 13, so it's -13y on both sides. Okay? So the 13s are gone. Well, I want the y's over here on the right, so I need the 2 to come over here. So I'm going to add the 2 and add the 2. The 2's are gone. So now I have y's on the left, on the right. 15 minus 13 would be 2y. And 4 plus 2 would be 6. And divides both sides by 2. So y equals 3. Okay, if you need to go back through this one again, I would just say stop the video, back it up just a little bit, and come back and look through this again. Okay, the balance of the seesaw, we want variables on one side, numbers on the other. Now, if you have parentheses on the problems, parentheses need to be, we need a distributive property. So be careful when you've got a negative that's going to go in the parentheses, because you have to think in terms of signs and what you're multiplying. So here I have a 7 to be multiplied and distributed. I have a 4 to be distributed. We did this in the beginning of chapter 1, so you've already done this. So distribute 7 times n. The number in front of the n is a 1. You're just multiplying those numbers. 7 times 1, so that's 7n, minus 7 times 6 would be 42. And then I've got a +8 right here. Over here, I'm going to have 4 times 1, so 4n, and 4 times -7 would be -28. Now, that problem looks like these up here. So, combine like terms on this one. I've got 7n, and I have a -42, and I'm going to pay back $8 of it. Okay, so I still owe money, but it's not going to be as much. So 42, take away 8, would be 34. And over here I have 4n minus 28. Okay, so now we need to get the variables on the left, or the variables on one side and the numbers on the other. If I bring the 4 over to the 7, subtract 4, my answer will be positive. So I'm going to work that way. I'm going to subtract the 4n. Okay, so that's gone. Then I get 3n. So that means if I bring the n's on this side, the numbers have to go this way. So I'm going to add 34 and add 34. So the 34 is gone. So I've gotten rid of something on one side and moved it, and got rid of this on this side and moved it here. So I have 3n equals, I owed 28 and I paid 34. So this time I got a positive answer. So 34 minus 28 would be 6. And I'm going to divide by 3. So n equals 2. Now on the next one, on number 8, the thing you have to be careful with is that this 7 has a negative sign on it. That means the negative and the 7 has to get multiplied into the parentheses. For right now, that 3x is just going to sit there and wait. Then you're going to distribute. So -7 times 7 would be -49. And -7 times -x. So negative times negative, the thing that happens is this becomes positive 7x equals 5. Okay, so 3 plus 7, I'm going to combine these x's together and get 10x. And then I'm going to add, I'm going to get rid, oops, let me rewrite this. Minus 49 equals 5. Now I want to get the 49 over, so I'm going to add 49. And I have 10x equals 54. And divide by 10, divide by 10. Now, 10 will not go evenly into 54. So what you can do is just reduce each one. They'll both divide by 2. So x is going to equal to 27 over 5. Okay, keep the fraction, but reduce it to lowest terms. Okay, on number 9, let me circle that. On number 9, distribute. Now, this is an understood 1 in front of that parentheses. So basically, we're multiplying everything by a negative 1. The number won't change, the numbers won't change, but their signs will change. So on the left, I'm keeping the 5x plus 4. And on the right, I'm now going to have 13. Negative 1 times positive 2 will be negative 2x. Negative 1 times negative 5 will be positive 5. Then you can go back and combine over here, and you'll have 5x plus 4 equals 18 minus 2x. Combine your like terms. If I bring the negative 2, add it on both sides. When I bring it over to the left, it'll turn positive. So I'm going to add 2x. That means the x's are gone from the right. And then I'll get 7x. I'm going to subtract the 4. So it's gone from this side, moved over to the right. So 18 minus 4 will be 14. And when I divide by 7, x will equal 2. So these are pretty simple problems, but it's just a matter of having practice and doing them again. When you have these kind of problems, you gotta slow down. You can't be in a hurry. You gotta pay attention to what you're doing. Make sure your signs are right. Write out all of your steps, and don't try to do everything in your head. Write out and show all your work. So here we've got a double combination of things. Now, remember, in order to get rid of the fractions, we need a common denominator. Okay, and we need a number that 5 and 3 will both go into. A number 5 and 3 will both go into. Well, it's simple enough to find a common denominator like this because they don't have anything in common. So you just multiply them together. So our LCD will be 15. Now, here's the deal. When we have parentheses with a number in front of it, we don't multiply the inside by the common denominator. We multiply the outside times the common denominator. Okay, it's kind of like this concept. If I have 4 times 2 times 3, okay, I'm going to multiply the first two together. 4 times 2 would be 8, and then I multiply 8 times that number. I don't multiply 4 times 2, then 4 times 3. I multiply 2 at a time and then multiply what's left over, and I would get 24. Same thing happens here. So I'm going to multiply, I'm going to put brackets because I've already got parentheses in there. And I'm going to multiply by 15. So 15 times 2, because 2 only has a 1 underneath it, just 15 times 2 would just be a regular number, 30. Now when I go over to here, I'm only going to multiply the fraction. And over here when I do 15, I'm only going to multiply the fraction. So 15, the 5 and the 15 will cancel. So 5 goes into 15 3 times, so that means minus 3, then still put your parentheses there. Don't multiply 15 times the parentheses, only multiply times the number in front. Then over here, 3 goes into 15, so I can cancel the 3, that would give me 5. 5 times 2 would give me 10, and then in the parentheses I have 2x minus 1. Okay, so we still have to come back and distribute, but what we've done with the 15 is eliminate the fraction that was out in front of the parentheses. Now go back and it's going to work just like the ones up here. So I have 30 minus distribute, that'll be negative 3 times x, so negative 3x. negative 3 times negative 1 will be positive 3. Over here, distribute the 10. So 10 times 2 would be 20x. And 10 times negative 1 would be negative 10. Now, I know that there is a problem like this on your chapter test for this. So make sure that you've got this one as an example. Alright, combine like terms. So I've got a positive 30 and a positive 3, which is going to give me 33 minus 3x. And over here, 20x minus 10. If I take the 20, that would be negative 20, and moving it over here, it's going to end up being negative. I like to keep things on the positive side because you don't have as many negative signs to worry about. So I'm going to take the 3 and move it to the 20. So add 3. So you're adding 3x. Be sure when you show this step that you put the x there because it needs to have an x there. Okay, so the 3x's are gone. And I've got 20 plus 3 would be 23x. Now the 10 is going to have to move with the 33. So I'm going to add 10 and add 10. So that's gone. And so I have 43 equals 23x. And then I'm going to divide both sides by 23. And I look at the problem and I have x equals 43 over 23. Well, 43 over 23 is not going to go even. So it's just a fraction, and we just leave it like that. So here's our answer. We don't need to change anything. Okay? We can't divide it. There's no reason to get a weird looking decimal value, so that's what we're going to work with. Okay, now there's two situations that you have to work with occasionally, and that is that not every problem has an answer. So sometimes your answer can come out to be that you have no solution, or sometimes you have an answer that says any number that you choose would work. So we have two other situations that we could work with. Now, what's going to happen is you're going to find out that as you work, your variables will probably all subtract off. So here's the situation. When the variables subtract off, that's going to leave you with just a comparison between two numbers. So it will be, say, like 5 equals negative 3. Okay, or 7 equals 7. Well, that will determine whether it's no solution or all real numbers. So if you get an answer that's false, okay, which would be the situation here, 5 does not equal negative 3. If it's a false statement, it's going to be no solution. Okay? If all the variables subtract off and you get an answer that's a true statement, 7 equals 7, so this would be true, then it's going to be all real numbers. Okay? So that's what the two situations can be. So now, distribute wherever you can, distribute. So I have 6y minus 18 plus 7 equals 6y plus 14 minus 1. So combine like terms, I'm going to get 6y minus 11 equals 6y plus 13. Now, if I try to get my variables together, when I subtract 6y, it's going to cancel off on both sides. So I'm left with a negative 11 equals a 13. True or false? Well, it's false. So your answer is no solution. Now, on these problems, that'll give you a drop-down menu choice. So all real numbers can be written with a symbol sometimes. It looks like this. So it's like a double, it's like an R with two lines in the front. That's an all real number symbol. No solution on the drop down. If it's a false statement, it would be no solution. And no solution is simply a 0 with a slash through it. So we work in terms of symbols here because we're math terms. So everything is in symbols. So you'll use symbols for these on a test. A symbol here for 0 with a slash means no solution. And if everything works, any number works because it's true, you can use that. Alright, so let's distribute. I'm going to distribute the negative 4, so negative 4y. Be careful when you multiply here. Negative times negative, so that's positive 8. And over here, this says I'm going to just change everything in here because that's a negative 1. So multiply by negative 1, I'm going to get negative 4y. And negative 1 times negative 1 is going to be positive 1. And then I have plus 9. So combine, I have negative 4y plus 8 equals negative 4y. Oh, and this is minus 9. Sorry, I copied that wrong. Minus 9 would be, oh, that should be a plus. Make that a plus. And that should, oh, that's not working. No, that's minus is right. Minus is right. Okay, and then minus 8, and that should be right. Well, this should be a plus. So this would be a minus, this would be a minus. Okay, there's a typo on these notes right here, so we're going to make that right. Okay, so now I've got negative 4y minus 8 and negative 4y minus 8. So now everything's the same. So if I subtract the y's off, add 4y and add 4y, those are going to be gone, and I get negative 8 equals negative 8. So negative 8 equals negative 8 is a true statement. Then our answer is all real numbers. Okay, this will be, this probably will be corrected on your page. That should be a minus 9. Still a minus 9. This should be a plus on the 2. Alright, so I hope this helps you, and if you miss class, then this is one of the things that can help you be able to learn this material. Bye.